Hello everyone, welcome back to my channel. So in this video, I'm going to explain about AC through pure capacitor from the subject name called Elements of Electrical Engineering, especially for first year engineering students. So now let us consider a pure capacitor which is connected across voltage source V. Whenever the voltage which is applied to the capacitor, current starts to flows through the capacitor and it starts to charge. This capacitor starts to charge. So that charge is given by C into V, whereas V is nothing but instantaneous value of voltage. So before that, let me define the supply voltage. V is given by Vm sine omega t. We'll give this as equation number 1 and it is a reference. Voltage is reference. So now whenever the supply which is given to the capacitor, this capacitor starts to charge. Capacitor starts to charge. So that charge is given by Q equals to C into V. Q equals C into V. So that now I'll define current. So current is nothing but a rate of change of charge, that is dq divided by dt. So now I'll substitute the value of charge in current equation. So I can get now I equals d by dt of C into V. Whereas V is instantaneous value of voltage is given by Vm sine omega t. So that I will substitute the value of V now. So it will be nothing but d divided by dt of C into Vm sine omega t. So now differentiate sine omega t with respect to dt. So you can get I equals, so I will take C and Vm outside. So d by dt of sine omega t. Differentiation of sine omega t with respect to t is nothing but omega into cos omega t. So that you can write I equals to C into Vm into omega cos omega t. So I'll rewrite this Vm into omega c into cos omega t. Okay. So now I'll rearrange this expression. Instead of writing omega c, I can also write like this Vm divided by 1 by omega c. It is nothing but Vm into omega c only. And we know that cos omega t is nothing but sine omega t plus pi by 2. So that I will substitute here. You can get sine omega t plus pi by 2 here. So this equation, I can give this as equation number A. Compare equation A with standard equation is given by I equals to Im sine omega t plus phi. So now what is Im? So Im is nothing but Vm divided by 1 over omega c. So that we'll write here Im is nothing but I will continue here. Im is nothing but Vm divided by 1 over omega c, whereas omega is nothing but 2 pi f, so that I can write here Vm divided by 1 divided by 2 pi f into c, and we know that again Xc is nothing but capacitive reactance, which is given by 1 divided by 2 pi f into c, so that instead of that I will write here Im equals Vm divided by xc. So now we compare phase angle phi. So phi is nothing but plus pi by 2. So plus pi by 2, it is nothing but 90 degree. That is phase angle of current. So now with the help of this, let's draw the phasor diagram. Before that, once again, I will write Im is nothing but Vm divided by Xc, and the phase angle of current is plus pi by 2, and phase angle of voltage is 0 degree, so that the angle between voltage and current is plus pi by 2, and the reference is voltage, so that by taking voltage as a reference, current leads the voltage at an angle of 90 degree. This is a phasor diagram. By taking voltage as a reference, current which leads the voltage at an angle of 90 degree. So now let's draw the waveforms of voltage and current. So now the voltage, which is a pure sinusoidal waveform because it is a supply voltage with respect to omega t. So in a y-axis, if you're taking voltage and current, the voltage waveform, okay, from voltage waveform, pure sinusoidal waveform, like this. 0 to pi by 2, sorry, 0 to pi, pi to 2 pi, 3 pi, 4 pi, and this is voltage waveform Vm sine omega t. So now current which leads the voltage, leading is nothing but positive again. It has to start from positive waveform, but it is leading by 90 degree. So that this current waveform is leading the voltage waveform. So the current waveform should start from 90 degree positive half cycle. So here the current waveform will be starting from pi by 2. So that a leading waveform, but the magnitude of or its amplitude of current waveform that will be less than the amplitude of voltage waveform. So that this is current waveform. Current is leading the voltage at an angle of 90 degree. Leading current, so that positive half cycle, from positive half cycle it will start. Like that it will continue. So this is nothing but Im sine omega t plus leading waveform, that is nothing but it is leading by 90 degrees, so that current waveform comes first, voltage waveform comes next, because if we are considering this phasor diagram, the rotation is anti-clockwise, so that the current is leading the voltage at an angle of 90 degree, or else the voltage which is lagging the current at an angle of 90 degree. Similarly, we need to write power. So for writing the power equation again, you need to define instantaneous value of power P. So power, you defined power with the help of instantaneous value of power P, that is given by instantaneous value of voltage into instantaneous value of current, V into I. Whereas V is nothing but Vm sine omega t, and I is nothing but Im sine omega t plus pi by 2, whereas Im is Vm by Xc. So you substitute here, you can get instantaneous value of power, which is given by Vm sine omega t into Im sine omega t plus pi by 2. So you can read it as Vm into Im sine omega t, whereas sine omega t plus pi by 2, we know that, we will write here, we know that sine omega t plus pi by 2 is nothing but cos omega t. Cos omega t. So that you can write it as Vm into Im sine omega t into cos omega t. And I already told in a previous video, sine omega t into cos omega t is nothing but sine 2 omega t. I'll rewrite once again. You know that sine 2 omega t is given by 2 sine omega t into cos omega t. So that sine omega t into cos omega t is given by sine 2 omega t divided by 2 according to trigonometry basics. So that you can write here Vm into Im sine 2 omega t divided by 2. Whereas you can observe this power waveform, this is a fluctuating power component, whereas it has a frequency that is 2 omega t, frequency which is double the frequency of applied voltage. So that is nothing but average power will be zero in capacitor. So there is no power consumption, no power consumption in inductor and capacitor, so that average power in L and C is zero. So now you need to draw the waveform of power. Instant is 90 degree because angle between voltage and current is 90 degrees. So that pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2. So you have to take the instants of power as 90 degree. Why 90 degree instant? Because the angle between voltage and current is 90 degree. So from 0 to 90 degree, you observe voltage waveform is positive, current waveform is positive, so that power is also positive. So you can get power waveform that is positive. Similarly, pi by 2 to pi, you can observe here this instant. So voltage is positive, current is negative, so that power is also negative. Plus into minus is minus. You can get negative waveform here. Similarly, pi to 2, 3 pi by 2, voltage is negative, current is negative, so that you can get positive waveform of power. You can see. And the cycle which continues like this. For the next waveform, that will be negative. Again, for the next, it is positive. So the waveform of power that will continues like this. And the average power that will be zero. As a power which is not having any direction, if it has a direction means average power of these two waveform that will be zero. And this is about AC through pure capacitance. So if you have any doubts regarding this, feel free to write in a comment box. I hope you understand the concept, so that kindly do subscribe and share maximum. Thank you. Have a nice day.